Hi, okay, welcome to session 9. We are focusing in on volume, and we're also going to apply volume into questions that involve maths and density as well, just so that we can make those links all together in the same session. We're going to start off with our recap. This is a full A4, which is obviously available to you to print and work on. If you're not printing, if you're working from the screen, then I'm just going to scroll through this. So it's a fairly decent size for you to work from. I'll do the same for the answers in a moment. So obviously pause at the appropriate point for viewing and then let it play on to those answers. Okay, and your answers are here. There we go, that's all of them. So I did want to just point out just a couple, really. I'm not going to say a massive amount. Question 6, I really wanted to just point out that sometimes they're not going to say work out the surface area and literally, make it stand out. This is what you have to do. This type of question is talking about wrapping up a solid. So you're covering the surface when you wrap it. And so you have to consider that context and make that link to surface area yourself. Now we'll see much more of this in our recaps, so you'll get to practice it, but it is important that you are always thinking about that context when they're not giving you the kind of key words. The last question, question 8, is hard. It is grade 5. So if it's feeling challenging, there is a good reason for it. Just remember to make that split so that you're doing it in those 2 parts. And then when they come together at the end, that X is like coming on top of that X. And that's how you're getting that final answer. You're just pushing the 2 together. Don't make it any more complicated than that. All right. Okay, hopefully the recap has gone well. Zoom that through. So, on to volume. Now, I said in the last session, if you're good at area, if you know those formulas, then you should be able to do surface area and volume with ease. And I really mean with ease, because the main skill is still area. So we know from our last session that a 3D shape starts life as a 2D shape. So I've got a 2D triangle, and once I put on that third length, okay, so that's my third length going in. Once I've put that third length in, sorry, it's a bit wobbly, it becomes 3D. So I've got my 2D shape and my third length. And that would be true of any prism, as we know. So I'll just sketch this in. It's not, again, going to be perfect, but it's going to show that same principle. If I can find the area of this and recognize which edge is the third length, the edge that creates the 3D shape. And again, one of the ways to think about this is to take a corner. If I take this corner, those 2 edges made my 2D shape. Having a third edge come out of it creates the 3D, and then, that opportunity to work on volume. So they're all the same. This is no different. I might as well do it as I've prepared it. So there is my really rubbish drawing, and you've got that front face. If you can find the area of that and you can recognize the third length there, that's all you need to be able to do. And then you've got volume, absolutely nailed. So we do give it a formula. I call it area of front face times by, whoops. Oh, let me rewrite that. That's looking a bit scruffy, isn't it? There we go. Times by third length. Area front face the front face changes. It could be a triangle, it can be a trapezium, it can be an L, it could be a circle, it could be any 2D shape, basically. So you've got the area of the front face, that's where the work is. And then it's just boom, times by one other number. By whatever the third length is, that's all it is. So don't, again, allow volume to be this big topic to learn. You know area, you know volume, okay? So that is our first example or question. I would love for you to just take that formula that I've spoken about, area of the front face times by the third length, and just have a go at that question. You have all the skills already. And then press play when you're ready. Okay, so the area of the front face is going to be the area of the triangle. Okay, that's base times height divided by 2. Okay, the base is 6, the height is 5.8. When I divide that by 2, I get, what do I get? I need to pop it in the calculator, I think. 6 times 5.8 divided by 2, I get 17.4. There we go. And I'm going to times that through by the third length. The third length is 9. And 17.4 times 9 is 156.6 centimeters. And now we're working in that 3D volume. So it's cubed as the power on our units. Okay, so 156.6 centimeters cubed. And that is it. I did the area of the front face, which was this bit here, times by the third length. And hopefully you did the same and you got it right. And if you did, really, really well done. Okay, let's do this question. Again, I want you to just have a go and then hit play when you're ready. Okay, now I could mess around with splitting this into rectangle and triangle, but because I can recognize that trapezium and the symmetry means that it's two identical trapeziums, I'm going to use my trapezium rule. So I've got, let's pop that there. Those are my A and my B. So 9 plus 6 times by the height, which is the distance between them. Okay, that's a rotated trapezium, so it doesn't feel like a height because it's horizontal, but it's got that right angle. All right, so it is times through by 4, not 8, because I only want that much of the edge that they've given me. Obviously, divided by 2 is the formula for the trapezium. I am then going to multiply by 2 because I have 2 identical trapeziums. And when I put that in my calculator, I get 60 coming out. So my area of the front face is this working out here, and it is 60. I'm timesing that by the third length. The third length is that one, the one that creates the 3D shape for me. So I'm going to be timesing that through by 5. It's going to give me 300 centimeters cubed because I'm finding volume. So it doesn't matter what that front face is, that's where the work is. I'm doing my area, and once I've got that, boom, straight through with that one extra number being multiplied in. Okay, let's do a slightly different question, okay? I'm going to draw a cuboid. Oh, hopefully. One, go back, This is not going to work out, guys. I have made a mess of it. Okay, let's just say that that is the worst cuboid ever. Should we try again? In fact, I'm just going to do it by hand. I think it'll be better than using the actual straight line bit. There we go. Okay, so I've got this cuboid. I'm going to say that this is 9. This is 6. This edge is X. I'm going to tell you the volume is 172.8 centimeters cubed. You have to work out X. Okay, you have to work out X. So hit pause and press play when you are ready. Okay, so what I should be doing in an exam situation with a question that's different is I should be thinking, okay, what am I looking at? What do I know? I'm looking at the word volume. So I should know that that is the area of the front face times by the third length. And I should write that down so that I don't lose that information and that knowledge when I go back and start looking at more detail. The area of the front face, okay, is here. So that is 9 times the edge that's labeled X. So I've got 9 times X. I can't do any more than write that down. I don't know what X is, but it is part of my working out. So I'm just going to put it in where it lives and see what happens. I then time through by the third length. The third length is 6. When I tidy all of that up using my rules of algebra, I end up with 9 times 6, which is 54, and then the X squashes into it. And I know that this here is the volume of the cuboid because I've used the formula. So this is the volume. And I know that this is the volume as a numerical answer. So I can put these two together because they are the same thing. I know that 54 times something is going to give me 172.8. Now, if I want to know what X is, I get it on its own. So I'm going to divide through by that 54. And it tells me that X is equal to 3.2. And it is centimeters because the volume is centimeters cubed. And if you got that right, really, really well done. Sometimes using a formula in a kind of backwards way can be really tricky. So, you know, getting that opportunity to do it. Your formula is your formula and it works. It works even when the question feels different. So you've got to have that trust and confidence to stick with it, all right, even when it starts to get a little tricky. Okay, so that's volume in a nutshell. I have got this as a sheet that you can print. I'm going to just scroll through it slowly for those of you that want to work from your screen. And then we've got the answers. And then we've got the second part of this, which is where we start to apply the volume to questions where capacity or mass and density could come in. So we want to see these links all at the same time. That makes good sense. So if you need a break so that you come back to it when you're feeling a little fresher, because I think you should always stop when you feel a bit like you're full up. You can't actually take any more information in. And if you're getting to that stage, it's really important to rest and make the next part of this video a separate session to study, okay? All right, so let's scroll slowly through. The answers. Okay, well done. So obviously you can see that, again, I kind of put an image together to help me. I could see that by turning it on itself, I could make the dimensions work with the box much, much better. So that's what I chose to do in order to solve that problem. And modeling in this way of drawing diagrams to get a feel for what's happening, it's really, really good. So it's not something that you're used to doing. It's something that I would encourage massively. They're not looking to judge your diagrams, but if they help you get through a problem, then they're brilliant, no matter what they look like. Okay, they're really, really good. Okay, so mass density volume, we are moving on. So if you've taken a break and you've come back to this, probably sensible, well done you. If you haven't, are you absolutely sure you want to keep going? It's just a few examples and then another worksheet for you to practice, all right? So let's first of all talk about the formula triangle. Okay, we've got mass density volume, and it's really important that we get these into the right positions. So if you didn't do the set 1 course, then you won't have seen this. If you did, it's going to feel like I'm repeating myself, but I think it's really important to share this. So if you haven't seen it, this will be important to you. There's another formula triangle that is for speed, distance, time, and those 3 will go in this order. So the first letter of the alphabet is the way a lot of people remember it. D is first letter to come up in the alphabet, and so we stick it on top. Now, I mean, there's nothing wrong with it, apart from you could run the risk of sticking the D in mass density volume in the top, because you kind of trained your brain to think like that. So what I have done and what I do in class to help students make sure they get this the right way round is to see in this triangle, the M and the D is mum and dad. When mum and dad are about together, mum's in charge. She's on top, okay? But when she's not around, and she is nowhere to be seen in the DST triangle, there is no M. So when mum isn't around, dad's on top. And I know it sounds a bit silly, but again, when you can come up with something that's just, you know, going to help trigger that memory, that's all we're trying to do at the end of the day. Okay, so we've got our mass density volume triangle, and we have got this capacity fact, okay? And this one's really, really important to remember as well. So 1 litre is equal to 1,000 centimetres cubed. Now there are obviously conversions for meters as well, and millimeters, etc., but you don't want to be remembering loads and loads of different facts. You want to remember one, remember it really well, so you've got it, and then work to it. So we're going to use this because it's the easiest one to remember. So a litre is 1,000 centimetres cubed. And then if we have to work in capacity, so capacity is liquid, so it could be that I'm filling a fish tank, and that's a really common question, and certainly one that I've used in this session. All right, or I'm filling a swimming pool or a pond or whatever it is. But if I've got some liquid involved, now I'm talking about capacity. It's still liquid filling a space. So volume is the space inside a 3D shape, and the liquid is filling the space inside a 3D shape. So it's still volume, but I cannot convert whatever it is to litres unless I'm in centimetres cubed. So if they give me the question in meters, I've got to remember to change it, because I'm going to need to do my litre conversion using centimetres cubed. And we'll see that coming up. So these 2 are really, really important for you to remember. Okay, because if they start talking about liquid, you've got to work in litres, and that means you've got to know how to change. All right. Okay, so let us go through an example. There it is, the famous fish tank. Okay. So this fish tank is going to be 80% filled with water. How many litres will it take? Okay, now there is no mention of volume whatsoever in this question. And there's a lot going on because I'm reading 80%. So now I'm thinking, oh God, it's a percentage question, which is taking me away from the fact that actually it's a volume question. So you've got to be really careful about percentages because they will do things like this. And then it can steer you kind of in a direction that's not really the right direction. That 80% is important, but it's not anything to do with the first step. All right. Now, if you think that you've got a good idea of how to get going with this question, then by all means, hit pause, play around with it. I'd love you to do that rather than just watch the video. Play around, get a feel for it. And then when you are watching it through, you can be looking at the things you did compared to the things I'm doing, what went well, what is different and why. And it can be a really, really fabulous way of learning. So press pause and then hit play when you are ready. Okay, so the first thing I need to know is actually how much liquid would fit into the entire shape. So I need the volume of the entire shape. I know because they're talking about liters, I'm going to need my 1 liter equals 1,000 centimeters cubed. I need that fact. So that's the first thing. That means I must be working in centimeters. I am on all the edges apart from this one here. So we're going to change that to 120 centimeters so that I've got everything in the right order. Okay, so volume is area of the front face times by the third length. My front face is here. So that's 120 times by 50, and third length is 60. I put that into my calculator and I work out that I've got 36 and then 4 zeros, so 360,000 centimeters cubed. Okay, now I only want 80% of that volume to be filled with water, not 100%. So that volume currently is 100% of the tank. So I now am going to work out my 80% of that value. 80% means 80 over 100. 80% of the volume is what I'm working out. Of means times. The volume is this. And that is going, so you can divide by the bottom times by the top. If you have to do it by hand, you can pop it in a calculator. These types of questions are pretty much always on calculators. They really want to know if you can work your way through a problem like this. And they don't want you to be hindered by having to work out every step of the maths. They want the calculator to do that. So that's why you'll pretty much always see this. So now we're thinking about changing this into liters. Now you don't have to do it like this, but I want to show it. All right, we've got a method that you may have seen in other courses called boxes and labels. And when you've got a fact like liters to centimeters cubed, they can go into the grid. And then you can use it to help you work out what's going on, okay? I want to change 288,000 centimeters cubed, hence me writing it in this column, into liters, okay? So I divide by the trapped number. So I do 288, divide it by 1,000, and then you times through by the third number in the box, but that's 1, it's not going to make any difference. So when I divide by 1,000, I get 288 liters, and that's the final answer. Now you may have done it in a slightly different order. You may have got to this stage, then changed it into liters, and then found 80% of that. it's all good. It all works. There is no right pathway, but the end result should be the same. And as long as you've got all your workings out to back up your answer, it's absolutely fine. So you don't have to worry about it. So that's an example of a wordy question that's using that area of a front face times by the third length and bringing something more to the table, so to speak. Okay, so we do need to be prepared for that type of thing. Let's put it that way. Okay, so we're going to have a look at a different type of question now. So let's clean all of this up. And I think we'll keep the cuboid, save me having to draw another one. And just pop on some new dimensions. So I'm going to say we've got 5 meters, 3 meters, and 2 meters. And this is going to be our question. So the density of the block is 6 kilograms per meter cubed. And you've got to work out the mass. So like I say, in your GCSE, you're always looking for those keywords. You're always looking for those trigger words that's going to trigger you into the right method or the right area to start working. And obviously our keywords would be density. I mean, you wouldn't even need to worry about that. As soon as you've read density, you know it's going to be that formula triangle. So it should really be the first thing that you draw: mass, density, volume. Okay. So even though the question itself had no mention whatsoever with volume, you have to have volume to work out the mass. Yeah, we're trying to work out this. So the mass is equal to density times volume. Well, I've got the density in the question, happy days, but no one's given me the volume. So this is, again, how volume can be brought in without any mention of it whatsoever. And if you don't trigger that triangle, which then triggers the V and the volume, you're kind of stuck before you get started. So really, really important. We learn these words and we make them trigger that crucial detail, which will take us on to solve the question. So the volume is the area of the front face times by the third length. So I have got 5 times 2 for the front face times 3. That is going to give me 30 meters cubed. If the density is 6 and the volume is 30, then the mass is going to be 180. And then what are my units? Okay. So you go back to the question and you look for those units. Density is, in this question, kilograms per meters cubed. Meters cubed linked to my volume. Kilograms links to the mass. Okay. If we just take a quick look at that formula triangle, okay, mass, kilograms, volume, meters cubed, density is equal to mass divided by volume. So kilograms per meters cubed, grams per centimeters cubed, whatever's in the question. Okay. It's just a case of reading through carefully, picking out the right information, and then just kind of pulling it all together. Every question like this is different, which is why, you know, a lot of students will struggle with it, because a lot of students fall into a trap of trying to recognize questions. I want to see this because I can answer this. So if it's given in a slightly different way, you're automatically stuck. And that's one of the biggest things that I want you to be thinking about when you're doing these courses in each session. I want you to be thinking about the fact that you are taking in methods and language and knowledge and tips and tricks, you know, so they become tools, so that it doesn't matter what the question looks like. You will be able to say, oh, that word triggers this, which means I do this, which means I do this. And then you're away and you're able to access the question rather than looking at something going, I've never answered a question like that before, so I can't do it. And you kind of shut down straight away. So everything we're doing is about opening up questions you've never seen before and being able to make a start on them rather than having that opposite effect. Okay, one last thing before I bring the worksheet up. So I did want to just mention front face to you. Front face is something that I use. It's not something you'll see in a textbook, probably isn't something that you're going to see in any other video anywhere. It's very much something I use because it's easier to remember than what you would see. So you might have teachers in schools or textbooks referring to the cross section. It's the same thing. All right. So if you've been wondering, well, I've always thought cross section, that is what my front face is. My front face is a cross section. All right. I just feel it's an easier way to remember, and that's why I do it. Okay. I'm going to, again, this is something you can print. I've got the worksheet available for you. If you're working from the screen, I will do the normal. I will scroll through slowly so you can pause at the appropriate point, and I will do the same with the answers. Okay, so that's volume in one session. Okay, so that's a lot of information. Just take your time with each of these questions. I'm going to disappear and I will see you next session. Really, really well done.